Sorry, right. Everyone's in now. Good morning, everyone. Thanks for joining us. Today, we welcome Nigel Banks from Ilke Homes, a pioneering modular housing company with a zero carbon design ethos. In this webinar, Nigel will set out how Ilke Homes are adding capacity to the housing sector and are delivering homes with guaranteed zero energy bills while focusing on minimising short-term carbon emissions, all in a financially viable way that the industry could roll out. Nigel is not looking to provide a puff piece on Ilke Homes. From my conversations I've had with him, I know it's important for him to provoke a great discussion with views that are contrary to other presentations that you may have seen on similar issues, such as whether we should be adopting Passivhaus specifications, be moving to CLT, and be installing more active equipment like solar PV and battery systems. So please use the chat function to post any questions you may have, whilst keeping your mics on mute until I invite you to unmute. Thank you very much. Lastly, before I ask Nigel to introduce himself, I would like to say that Meshwork is about to hit 2,000 members this week. Increasing numbers will allow us to continue to invite great speakers like Nigel and the many before him. So if there are any particular experts and specialists you'd like to hear from, do drop me a line using the chat function within Meshwork. Special thanks to Nihad, who I think is on the call, who's been using his referral button quite a lot this week and boosting our numbers. So yeah, it'd be interesting to see if anyone on this call could make a referral to introduce the 2,000th member. So that would be marvelous. Thank you very much. Nigel, good morning. Welcome to Meshwork.
Thank you very much. Great to be here.
Yeah. Let me, if you could just ask you to introduce yourself and then no doubt continue with your presentation. I will stop sharing my screen and then you can share yours.
Fantastic. Right, let me just do that and get that up. So yeah, good afternoon, everyone. So Nigel Banks, I'm R&D Director at Ilke Homes. Been with Ilke Homes since the very founding of the business just over 5 years ago. And as Simon says, look, I've got some slides. Hopefully there's some thought-provoking and challenging to some popular assumptions on certain topics that hopefully will create a bit of debate. So I'll do about half an hour presentation and hopefully that will provoke some interesting discussion on the end. So the topic there around viable solutions for more homes with zero bills and shorter term emissions is really around trying to look at it in a fairly holistic way. I think often I and others have probably been a bit carbon pigeonholed, and we are facing a really broad set of challenges or crises or emergencies, whether it be climate, housing, biodiversity, health, inequality, skills and trades and affordability and viability, and not got answers to all of these, but trying to cover some of those around how do we reduce emissions in the short term, how do we provide more additional sufficient safeties and housing, looking at particularly in inequalities and opportunity diversity in the workforce, something we're doing a lot on around skills, not necessarily trades, but building on the existing trades base that's there. And a big focus of mine from my work at Ilke and before that at Keepmoat and before that Econ was around low carbon, but also low running costs. I've done a lot of work on fuel poverty strategies, retrofit work in the past as well. But one of the reasons I moved from consulting into main contracting and now at Ilke is the ability to try and scale things up and make a difference. I was a bit fed up of working on massive projects in the Middle East that didn't make much of a difference here and wanted to make a big impact. So that's what I'm going to try and cover. I'm going to try and cover that topic of hopefully showing some ideas around that and showing some challenge on some of those as well. So I think for the first challenge is why do we need more homes? And I think there's a carbon argument to say we don't need more homes because more homes means more carbon generally. But there was an interesting article in the FT, again by John Byrne-Murdoch, who's done some great infographics on the number of homes per 1,000 people in the UK and other Anglophone countries is quite a long way behind other European countries. And some of the outcomes of that is a shortage of housing, which drives up pricing, both in private sale and in rent. And if we are going to have affordable housing for people to buy, rent and live in, part of the challenge is about building more homes so that supply keeps up with demand, and also obviously running costs as well. So I do think there is a need to build more homes in the UK, despite the carbon impact that's going to create. And part of the challenge is how to do that and minimise those impacts. The other challenge we've got, if you agree that you do need more homes, is you need enough people to build more homes. And this is some interesting work, again, from Twitter. Noble Francis has put out some charts based on the latest ONS figures. and nearly 500,000 workers in the construction industry as per end of last year are set to retire fairly soon in the next 10 years, and we're not recruiting in anywhere near the same volumes of people that are leaving. But interestingly, it isn't the 50s and 60-year-olds that are leaving the industry. It's the 40-year-olds and early 50-year-olds that are generally leaving the industry in quite significant numbers. And we're not replacing them with EU workers anymore, and not replacing them yet with non-EU workers. So as a result of that, we have got a shrinking demographic of construction skills. And the other key thing that we look at ilke is the particularly the gender diversity. Currently, we're fishing in half the population pool for skilled trades, plant operatives, and other elementary occupations, and less than 2% of those in the current construction workforce are female. So that's a real challenge. So I think we need to build more homes, but we need to build more homes and recruit more people in the industry, and we need to do it in a way that's attractive. And that's one of the main reasons we set up ilke in the first place. So got a little bit about ilke and what we're doing on that, and then I'm going to go on to zero bills and embodied carbon. So if you're not familiar with the ilke business, I'm based at the factory in the top left picture there, just in North Yorkshire. We're currently producing 4 homes a day, so it's equivalent to 1,000 homes a year. We only started 5 years ago, and we now have over 1,100 employees in the business. And 95% of the roles in the manufacturing who are building the homes have got no trade background, so a really diverse labour pool. So we're not taking people from construction sites and putting them in the shed to build houses. We are manufacturing and bringing people from a really diverse set of backgrounds, and I'll cover some of that. And another key thing was around getting accreditations. Getting modular accredited is very difficult. Happy to pick up any questions around that, but we were the first to get NHBC accepts, and BOPAS do a standard 60-year assessment, and we've done asked them to do, and the only ones to have a 100-year durability and maintenance assessment. So this little fly through hopefully will give you a bit of a feel for what we do at the business and why we're doing things differently and how we do things differently. So we've got a big in-house design team that are developing a portfolio of house types. We currently have 9 house types which we use on our sites. We have some automation. People from construction world think this is fairly good. People from manufacturing world think this is 1990s kit, and it is, but adapted for the size and scale of components that we're making. So generally, we have a reasonably high level of automation on some key components and sub-assemblies. So we make full wall panels, as you can see there. That's a party wall panel. We use a galvanized cold rolled steel frame, and it's a full modular category 1, so full 3D volumetric. We still have some fairly manual processes in the factory, including adding finishes, brick slips or render in the factory. So we finish the homes as far as we think is possible, both inside and out. So external finishes, bathrooms, radiators, all tested, kitchens fitted in the factory. So it leaves minimal work to do on site. So we're about 85% PMV, if you're in the world of understanding that, and most of that that's left is the foundation and groundworks. So houses, the modules are then transported to site, and the install process is done with a mobile crane. This is some of the early sites in 2018. We have a module per floor. So this is a pair of semi-detached, I think there are 3-bedroom houses in Kent. And within a couple of weeks, you've got a finished home. So that's the process we go through. And because we're manufacturing homes rather than using construction skills, we've got a very different workforce. So we very much see this as a manufacturing facility, not a construction site. At 2,000 homes a year, which is our full capacity, that is the equivalent of 40 or 50 main house builder sites, in terms of typically a main house builder would do 1 house a week. We'll be doing 40 or 50 houses a week at full capacity. So, and we're currently doing 20 houses a week. So about equivalent of probably about 20 main house builder sites in one location. There's a lot of benefits around people coming to the same location, employing people locally. There is clearly vehicle travel to get to the site, and from the site from the factory to the construction site. But that's generally local people rather than people traveling, which the construction trades tend to do more. So we now have a great team of people with really diverse set of backgrounds. We've got people who used to work in call centres, people who used to work in retail, we've got a former nun who is now doing finishing works. So a really diverse set of backgrounds, and really proud that we're already up to about 18% women on the construction workforce in terms of building the homes. and a short-term target to get to 30%, with an ultimate aim of getting that up to 50%. And we think that is achievable in the next decade to get to 50%, whereas we don't think it's probably that achievable in the construction sector. We've built across the country, and we're building for major house builders where we supply the superstructures. We're building for housing associations, and this is one of the recent schemes. So the homes hopefully look like a good quality new build housing scheme, and not a temporary prefab. This is permanent housing built to a high quality. And then we're also building for institutional investors, like those likes of Gresham House and Man Group. And the houses on the right there are our first zero bill homes, which have just been occupied. So why did we go for zero bills, and why have we set that as a standard, and why do we think that is something which we believe the industry should be adopting, perhaps in lieu of something like the Passivhaus standard? And I'll perhaps come into that, and that's probably where we'll get some discussion. So look, energy bills have gone up. If you look at the top line, from £1,000 to £2,500, they may drop down to £2,000 later this year. And there is depending on how well insulated your house is, an existing house can be a lot higher than that. New build houses typically are better on heating, but are pretty similar on electricity and hot water usage to an existing house, and that's generally where the difference occurs. Solar PV can help with bills, and people who've got solar systems that are working would generally say that does deliver a good benefit. But the areas we started to look at was how do we get lower than that, and we did a sort of an option study about 2 years ago saying how low could we go with bills, and realised that with a good fabric spec, heat pumps, PV, battery, and smart controls, we think we could get to zero bills. That was a concept that we launched in 2021, a sort of vision that by 2030 we'd only build zero carbon homes with zero bills, and we'd try and do that at zero extra cost by 2030. So that was a vision, and we knew we could do zero carbon because we'd done in operation. I'll come back to embodied carbon, zero carbon operation, because we knew we'd done some sites that had delivered that in theory and in practice in terms of some of the monitoring data. But zero bills was an idea, and we worked that idea up. We spoke to a lot of utilities and ended up working with Octopus. So Octopus Energy have now created a zero bills tariff that is available to homes that they accredit having the right equipment and the right fabric standards to deliver a guaranteed zero bill. So they will guarantee zero energy bill, no standing charge, as long as you build a house to a certain specification. There are some T's and C's. There is a cap on usage. It's more than a fair use. It's probably an excessive usage cap, and it excludes electric vehicle charging. But effectively, you need solar PV, and quite a lot of it, a good fabric spec, electric heating. If you haven't got a heat pump, you need to go further with your fabric, and battery storage. And effectively, Octopus control the battery and the heat pump based on the temperature settings that the customer does and lives normally, and they do the rest of it and can get the home to deliver a zero bill. So we've now delivered our first zero bills last year, and they're now just been occupied. And we're now getting the data back on the first homes that are performing in line with expectations. We built 2 on the first phase of this site, Hope Green and Stanford Hope. We've now got 22 on this site that is upgraded to zero bills, and we've got about 150 in our pipeline to build in the next sort of 18 months or so. So starting to get some real momentum. A really interesting point around this is around viability. So typically our zero carbon spec, and when I was previously at Keepmoat, we built a zero carbon home, or code 5.6, next to a code 3 home, and they sold for the same price because people weren't able to borrow more money to buy a higher performing home. The mortgage rate was the same. There are some lenders offering an A or B rated home with or a Passivhaus home with a slight discount or a cashback incentive, but fundamentally you couldn't borrow £20,000-30,000 more to pay the uplift for some of the equipment that was going in at that time. What we found now and are finding on sites going forward is on shared ownership and private sale and on private rent, you can charge a higher price and you can borrow more money to do that. When you do your affordability check for your mortgage, instead of putting £2,000 a year of energy bills in, you put 0 in, which unlocks £30,000-40,000 of extra borrowing capacity that wouldn't otherwise be there. So you can't use it to buy a bigger house. You can't use it to buy an upgraded kitchen, but you can use it to buy an upgraded energy spec. But the zero bill is the guarantee on the zero bill is really important. And the reason zero is important is it's rather than doing a fixed price, is if energy prices go up or down, they net to zero on the zero bills. And so it's kind of market agnostic. So Octopus can have confidence if the price goes up a lot, they'll be able to export for the same amount as they import and get to a net zero position again on price. And likewise, if the costs do come down, they can do that. If it was a guaranteed half price bill, that's harder for them to do. And what I would say around why we've looked at more active technologies and why we focused on PV and battery storage rather than just going on fabric is that there's diminishing returns. And Wimbish Passivhaus was a scheme I worked on at Keepmoat, but then Bramall. And it's had 10 years worth of monitoring, and it's really interesting seeing the monitoring data. The homes have performed very well on heating, but electricity use in particular is high, much higher than the PHPP suggested it would be, and much actually higher than the average or typical, generally in the average to high against typical existing homes. So they haven't tackled the electricity use. And actually, when you look at a bill now on a new build house, even a new build to the current standards built not that well, hot water and electricity usage is the biggest part of the bill, much more so than the heating. Whereas on an existing home, absolutely heating is important. So trying to combine a good fabric with the other technologies is where we think is the best way of getting to a zero bill. But absolutely recognise by doing that, you're adding quite a lot of embodied carbon, and that's the natural criticism that comes the way of adding more kit. But look, and we are focused on trying to work out how do we do that. And fundamental issue we've got is we've got to come up with solutions that reduce emissions in the short term. 60-year whole life carbon assessments, not really interested in, because that takes you out to 2080. By then, we've spent the carbon budgets we've got. We've got to come up with solutions that are lower carbon soon and lower carbon in the short term. And some of the things that are a bit counterintuitive start to come forward as a result of that. One of which is around choice of structural materials. This is an excellent paper from the iStructE journal that if anyone hasn't read it, it's worth reading. And it looks at the embodied carbon of different systems and understanding how important it is to be designing efficiently and not wastefully, irrespective of your material choice. So this compares over time. It's a sort of 100-year time cycle. So where it all jumps up on the sort of 2/3 of the way across, that's at 60 years. But the bit it points out is in a timber structure, you have got high embodied carbon at day one, and the trees that are planted that replace that tree absorb carbon out of the atmosphere over the next 40, 50 years and get down to a negative or neutral point of view. But what happens at end of life with timber also has a big impact. And timber used wastefully, and one of the things that I see, which I think is wasteful use of timber, is CLT in a 2-story structure. You need a stud every 600 mil, not a continuous 90 mil panel on a house. So some of that stuff feels to me that it's unnecessary use of material, which has a carbon footprint. I don't think the biogenic is a long-term benefit. And if you overlay that green bar, the time we've got over the next 20 years to reduce carbon emissions isn't around, is done through reducing the amount of materials used and trying to look at alternative materials that are low carbon in the short term. And in my mind, timber, steel, concrete all have high embodied carbon in the short term. If you're not, it's worth having a read the paper if you haven't seen that. So we've done a lot of work on minimising our materials. This is a bit of work done by the Future Homes Hub and Verco in their latest report on embodied carbon. And they've got, I think, about 40 data points from different house builders, timber frame, brick and block, and we put in our steel frame houses and compared the upfront and embodied carbon over a life cycle basis on different homes. And our homes were coming out some of the lowest upfront carbon of the different portfolio of types. Not saying you can't do better, but we're starting from a good position, having done a huge amount of work on material efficiency, and we've reduced our emissions by about a third since we started in 2017 on upfront carbon by designing out unnecessary components and lots of physical testing and optimization to achieve that. But we've got a long way to go. One of the other reasons I don't think going towards a Passivhaus spec at the moment makes a lot of sense on an embodied carbon argument. So the the Passivhaus Trust report shows a significant uplift in material use when you go to Passivhaus from building regs. Sort of doubling of insulation material doubles the embodied carbon in that insulation. I think the argument was that overall it was still better. And I have challenged that with the authors, and they've got different window assumptions and different heat pump assumptions, which if you equal those out, which I think they should be, because you should have, you've got timber, you should have timber in both for window frames, and it's the same size heat pump required in both because it's the hot water demand that's driving it. You get a quite different answer, and the extra MVHR and insulation will increase embodied carbon over the life cycle. And if you've got a heat pump providing the operational carbon, you don't get that carbon back. It doesn't. You don't make the savings. The savings don't recoup that extra over carbon ever. Not over 20 years. Not ever. Because the green is going to zero carbon very quickly. And I've done published some paper on that in the SIBSI journal if people are interested in understanding some of that. So where we're getting to in terms of our design philosophy is, look, good design, good quality should be fundamental and isn't fundamental. And I think a lot of the reasons why people are saying Passivhaus doesn't cost more is because it isn't designed as efficiently as or built in a as cost-effective way as it could do. If you take a standard house builder house and make it to Passivhaus, you'll add cost if you don't do anything else. If you can design it out to be more efficient, great, but you could also design that house builder house to be more efficient as well in terms of its material usage or glazing percentages or footprint or simplicity of fabric. So there is a balance around cost and carbon, and one of the issues that I see is more insulation going to triple glazing rather than double increases carbon, increases deliveries, increases cost. And if you're a housing association with a fixed budget, that means you'll build less houses or you'll retrofit less houses. But I acknowledge there are some co-benefits of potential health, air quality, etc. in a Passivhaus spec, but then that could be achieved in a good designed non-Passivhaus spec. And I think there's an interesting balance to be had. But one of the reasons we've looked at some of the more active technologies is the cost has moved in our direction. And also there's an interesting paper shown here around the cost of the lower carbon materials. And one of the real issues there is low carbon generally equals high cost. And so on cavity wall, some of the lowest carbon are the highest cost and some of the highest carbon are the lowest costs. There are some materials which are pretty good in both embodied carbon and costs, like EPS or lime stucco, but generally low carbon equals high cost. And there's some things which are high carbon and high cost, like brick, and we should be looking at alternatives. But the embodied carbon materials is a really interesting challenge. But on the cost point of view, insulation and glass have gone up massively in the last few years, which has made this problem even more exacerbated. So there's a carbon challenge, but insulation products have gone up 40% in the last year. So from a cost point of view, that diminishing returns from a carbon, I would argue, isn't there. And I think the diminishing returns of going from 150 mil cavities to 250 mil cavities on a house or a bungalow, I don't think the carbon or the cost can currently justify itself. Quality and design and efficiency and using less material, I think, makes more sense at the moment. So if you are going for, if the solution is going to that lower carbon materials to try and offset the fact that you need more of it, you've got even more cost, which potentially means even less homes being built or retrofit. So there's a real dilemma there, and I think that's why I think there's a sensible, nuanced position, which is a good level of design, a good level of engineering, a good level of insulation, but perhaps not going as far as you can, as some people are advocating. On the counter side to that, why do I still think it's worth the embodied carbon and the cost of the active components is the active components costs have come down massively, while some of the other products have been counter-inflationary. And although there was a bit of a rise last year on PV, it's come back down again this year. So we're about a third cheaper than pre-pandemic prices on PV. And battery prices continue to fall significantly. So that is getting cheaper while the cost of some of the insulation and the trades to fit that has gone up. So that, on the cost point of view, I think that is still making more sense. And the payback is there on a capex versus payback on a cash point of view. And there's an argument around the carbon point of view, that we will need to build more solar, a lot more solar in the UK as part of the balanced pathway, and building that on houses where the roof provides the frame rather than having to build a steel frame, for me makes sense, and it's used directly in the area rather than being in a remote solar farm, and has the benefits to the householders rather than being benefits to some solar developers. So in my mind, you have to build the solar PV anyway, in a solar farm or on a roof. I would prefer to put on a roof, and therefore I don't think you can see, I think you should measure the embodied carbon, but I'm not sure necessarily you should add it on to your, use it as a reason for not fitting solar PV, because we need to fit a lot more solar PV, and you can see there on the right hand chart a hell of a lot more PV. And we've done some analysis to say, does the carbon pay back on PV, even with a diminishing grid? And this is the sort of analysis we've done on insulation and other products as well. And we're seeing that upfront carbon does pay back on PV and battery combined. And over time, the replacement battery, the replacement inverter should be lower carbon, and hopefully the embodied carbon in the materials will also drop. There may be a point where that doesn't make sense, but as the grid goes really low carbon, but hopefully we will have some lower carbon ways of shipping and other issues, other solutions to some of those challenges by then. So this is my last slide, I think. So just go up to half now. So in summary, hopefully that's provided some interesting, thought-provoking ideas. So fundamentally, I think we should be focusing on good design, simplicity, wherever we can, to reduce and use good engineering to make efficient structures that are low upfront carbon, zero operational carbon. And we do need to be looking at some of those other materials, but if they are costing 3, 4, 5, 10 times as much, that isn't going to be viable. One thing I do think Passivhaus does brilliantly, and the whole industry needs to get behind, is the quality control approach from Passivhaus. So building it right, commissioning it, testing it, not substitute materials, not cutting corners, getting good designs, getting good details. That bit of Passivhaus I think is brilliant and should be adopted across the industry. Going from 150 to 250 to 300 mil insulation in wall cavities or external insulation doesn't feel right from an embodied or cost perspective. Performance monitoring, we're getting some great data back on our zero bills homes to actually understand how they were performing, how they're working. There's been a huge amount of homes built, in theory, performing well, that we don't know if they are performing well, and it is the only way to get that feedback. And I think there's a big focus on what are the viable technologies. At the moment, the more active technologies have become cheaper, the more passive technologies have got more expensive, and I don't think they deliver a cost or carbon payback at the moment. As materials and manufacturing become lower carbon, that will change. So I do think circa 2035, the argument around Passivhaus materials and that extra thickness materials could actually come back again, and because the materials will be could be lower carbon. But at the moment, my sort of philosophy at the moment is it doesn't make sense to go that far, and I think that's something which people should have a think about and see if they agree. So I hope that will provoke some thought and some discussion, and I'll finish it there for that discussion. So
thank you, Nigel. Yeah, very interesting. I mean, I like the nuanced approach. Seems realistic. I mean, especially for me. I mean, people who attend these webinars, they know that I'm a facilitator. I'm not a specialist. I'm not an expert in sustainability. So what appeals to me is like some of the big, like zero bills, where we, as a consumer, as a homeowner, the prospect of zero bills means that by virtue of wanting to live in a house with zero bills, we are then addressing the carbon issue as well. It's like we're not banging someone over the head. We're not constantly talking about, you need to fill out these forms. You can apply for solar grant, blah, 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 and you might get the money afterwards or whatever. Essentially with this, it's seamless. So you've devised a model whereby people want to live in a low carbon home because
it makes commercial sense.
It makes
that's the big driver. We think. Well, I'm interested in zero carbon. I bet the people on the call are probably interested in zero carbon.
Sure they are. Of course they are. That's what I hear.
Probably aren't, but they are interested in having zero bills, as we think it's a much better consumer proposition. So, Octopus have launched that tariff to other suppliers, other developers now. So any house builder, or client group can go, if you just Google Octopus Zero Bills, there's a web page with sort of FAQs, and get in touch with them. And they're, what I would say is, on a 80 square meter house, you need 9.5 kilowatts of PV, 10 kilowatt hours of battery, an air source heat pump, and a new building regs L21 or better fabric. Is kind of the spec requirements. So that does add cost, but what we're seeing is that extra cost is, well, the site we've got in Stamford Hope is, the homes are selling for more. The uplift is the sales uplift that the client is getting is greater than the cost that it costs them to buy off us. So they're making money, the customer's getting a good result. So for us, that's what makes it viable.
Yeah, win-win-win. I mean, the fact that it's become a commercial, that it's been commercial, we're now at a point where it makes sense commercially, is a game changer. And then for developers, it should be an exciting period, because at long last, you know, we have Oliver from Barratt Homes speaking in 2 or 3 weeks, and you know, people might often say, you know, they're late to the party, but until it becomes commercially viable, then it's going to be different. It's, you know, behaviours are not going to change. So I think this is quite incredible. Also, the way that you've addressed the skill shortage, you know, with it being a manufacturing process, not a construction process, you know. So are you seeing more home builders like yourselves coming online? I mean, it seems that is another way of addressing this issue. You know, you are continuing. Your focus is on having the ability to build more low carbon homes, not Absolutely. Which we clearly do need. And the way you've done it through the manufacturing process, especially when, you know, there's people struggling, you know, you're just addressing the skills shortage, which again is very, very clever.
Yeah, so I think, look, what I would say is, I think some of the major house builders are getting into timber frame as an easier first step. Like Persimmon, and I've got their own, and Crest, Countryside, now Vistry, and Barratt's have bought Oregon, so that they are getting into the sort of timber frame to try and reduce reliance on some trades. But what I would say is, it's not a simple thing to get a new modular housing factory going.
No, I'm sure.
Modular business going, and it does require quite deep pockets. But we're getting to the point now with the scale where it makes sense. You need to go for scale to get, and you have to fill a factory to make a factory work. So a factory that's only running half output isn't going to be profitable. So you need to get a factory up to that scale, and that's been our challenge to date. But we're now very much there. We're getting to the sort of volumes that gets to a break-even point, and hopefully profitable shortly. So that is a big challenge. But it's a big challenge we've got for the industry, is if we're limited with the tradespeople to build 200,000 homes a year, how are we going to get beyond that? Yeah. And at the moment, we don't see another solution. Whether Elon Musk's Tesla robot turns into a bricklayer, and solves that problem in 10 years' time, maybe. But for now, I don't think that is there's an easy solution to that, other than the sorts of solutions that we're doing, where effectively we are de-skilling. Well, not de-skilling. De-skilling is not the right word. So we are upskilling people in specific narrow windows of activity, and train them up to be able to deliver that activity quickly. So it's learning from some of the other manufacturing areas where they would train someone to do something in 60 seconds, like fit a carpet on a car, or fit a dashboard in 60 seconds. We're trying to train someone to be able to do 1 hour to 2 hours worth of work, and do that on a repetitive cycle, and then train them to be able to do other activities around the factory, so they can move around the factory and be useful and cover holidays and sick and etc. Still give them variety. So so you can train people to fit our kitchens in a few weeks, to be able to fit them in 1 hour. What you can't do is then say, right, go and fit a kitchen in a Barratt home, because they wouldn't have the skills to be able to do that. But they do have to be able to train a workforce very quickly. Yeah.
No, absolutely. And just on the point, before we go to some of the questions from the attendees, is from a finance perspective, there seems to be more and more finance companies who are specializing in this area. They're looking to fund these types of your type of company projects, etc. So and that will only increase, that pace of access will only increase as well. So
Yeah, we're seeing that, and it's interestingly, we thought originally the housing associations would be the first to really go for the zero bills, but it's been more the institutional finance that have gone for it. So like the Gresham House that have funded the first project. Some of that's their ESG funding behind them, and some of their internal requirements.
Yeah.
We still haven't solved, and if anyone's got the answer to it, please let us know, the challenge of making it really work in affordable rent, because rents are capped. So you can't put on a private rent, you can do an all-in rent with the energy bill included and charge a higher rent in private rent, but in social rent or affordable rent, you can't, because the rents are capped. So we do think some sort of fixed energy charge is probably the right way of doing it. But adding service charges to new houses is challenging and contentious, even if it's got a zero bill on energy. So that's one we're trying to try and work out how that can be done in a relatively straightforward way. But the rent caps do make that challenging, whereas private sale, shared ownership, build to rent, private rent, we think that is a fairly easy viability and financial case to make that work.
And then Ned's asked a question here. He said, how does the partnership work between Octopus and ilke? Presumably your build stroke tech, or their tech, what's their model? Did you want to cover that briefly?
So the way it works with Octopus and us, and it can work with Octopus and anyone else now, because they've broadened it out to really try and scale this in the UK and internationally. Actually, they're in 8 countries. They're trying to spread this globally, which is great. Is they've got a specification. You need to submit your predicted performance to them in terms of energy data and kit that's being specified, and they need to be able to control that kit. So they need to have a battery system that they're compatible with, a heat pump that they're compatible with. So effectively, we build it, and then they operate the smart controls of that kit, and they manage the customer billing. So they will still bill, but they'll bill for zero unless they go over their excessive use cap or have EV charging. But effectively, they are taking the risk on the house's performance and the user's behaviour to some extent. There is, in the contract, there is some come back to us if we designed a house and we said it's going to use a certain amount and it uses twice as much. There'll be some come back to us, but we're pretty confident around our performance of our houses from what we've done and what we've seen and what we're monitoring we've done. But effectively, that once we've built it and it's the risk sits with Octopus, but again, they've got a huge amount of data around how people use energy and how much energy people use for different things. And the big bit for them is they're moving when energy is drawn from the grid and when they're exporting energy back out to the grid. So they're trying to, in winter, they'll be trying to charge the battery and fill up the hot water tank in at night, when electricity, on a windy night when it's free or negative price electricity, and they'll be looking to, in the summer, to export the solar in the evening peak when they can get 30p a kilowatt hour rather than 3p a kilowatt hour for it in the afternoon. So, but the customer operates their house, uses their energy as normal. So we're not asking customers to shift their loads or do anything else. They've just got to set the programmer on the thermostat and live their life normally, and Octopus does the rest of it in the background. So it's definitely their smart controls, but it's the kit that we fitted on the houses that I think they are now starting to fit kit themselves. So I think they would install PV batteries and heat pumps for house builders. There's something that they're starting to roll out, but their secret sauce is the control and the management of energy flows in and out.
And for home buyers, am I right in thinking, is it a 5-year agreement? And then what happens after that 5 years? Presumably they're not then surcharged.
No. So the expectation is it will be an ongoing, indefinite tariff at zero, subject to the equipment being maintained and operational. But there were no. I think their CFO was nervous of guaranteeing anything beyond 5 years. So that's I think they were hoping to get out to 10 years, and I think they probably could. I think they want to see how the first few hundred go before they make commitments to go much beyond that. But the principle is this will work on an ongoing basis where the energy market's high or low. Actually, the more extreme the market becomes which is expected to happen with more renewables, the better result will be for Octopus effectively. And it may be that over time we can reduce the amount of PV or battery that's required to make it more applicable to other house types or into retrofit. They are looking to strike this into retrofit, but it's quite hard to get that much PV into and get the fabric up to a reasonable standard. But some of the energy strong type projects are achieving that, and probably some Enefit projects, if they had big enough roofs, could do it as well.
Yeah. No, interesting. Thank you. And then, sorry, just can I clarify? Did you take this idea to Octopus, or did they approach you as their first developer to see whether this could be pulled off?
So we had the concept back in sort of 2021. That's something we wanted to do to see if it was possible. And then it's kind of the story goes that our CEO Giles and Greg Jackson, CEO, had a dinner and talking heat pumps and said, Greg Jackson was like, yeah, we'll send us the stuff through and we'll have a look at it. So we had the concept. We thought it would work. We'd run some numbers that thought it would work, and then, but we can't do it on our own. We can't do it without Octopus to be able to do this. So it's very much a partnership.
Yeah.
And it has been a lot of backwards and forwards around what is the spec, how can we go hard, can we do things differently, and understanding where in the country it works as well.
Yeah.
So currently we're doing it sort of Midlands and South. We are trying to get up into the Northeast as well. May not, whether it's possible in Scotland. Don't know. That's you'd have to look at the basic sums are you need to generate 20 to 30% more than you expected to use.
Right.
To make it to a zero bill. So that's probably your benchmark.
Okay.
So yeah.
Cool. Just reading Rob's. Did you want to come off mute, Rob, or shall I ask it for you?
Oh, I can do if you like. Yeah.
Cool, thank you.
Yeah, we had a good presentation last week talking about how you evaluate something that's been built, whether it's HTC testing as well as airtightness testing, and building houses and making sure they work post occupation is really important. I was just curious as to what things you actually measure and how.
Yeah, so we, I mean, as everyone else do, we do airtightness testing as standard. We achieve between 3 and 4 out of the factory without pretty much having to do anything on site.
Mm-hmm.
And we use DMEV rather than MVHR from a maintenance perspective, and partly a life cycle carbon perspective, and where a lot of people have got different views on that, but I think in the market we're in, that is an appropriate solution to avoid filter changes, etc. So we air pressure testing, yes, and we do thermography now, thermal imaging. We've trained our own people to do that. We are looking at doing some HTC work. We did a project in Gateshead with Home Group, which was Gateshead Innovation Village, which had ongoing monitoring performance. Our homes performing consistently very well. That report hasn't been published yet, unfortunately, but that we're keen for that to come out. But the bit we're able to do with the batteries is we're able to see the generation, the use or demand, import, export, battery in and out of the grid and in and out of the battery on a sort of 5-minute basis. So you get really granular understanding of how things are working, how hard the pump working. And we're also linking to the API for the heat pump. So we'll see what the flow temperature on the heat pump, what the COP is of the heat pump is live, and the control temperatures that the household is setting. So the risk to me is, A, have we built it right and is it performing? And we've got some good data around that already. And we've got a high degree of consistency through our approach of manufacture. I think it's the user behaviors is the bit which is the really unknown source around people leaving windows open and turn the heating on because they've got zero bills, and what sort of rebound effects are we going to get? And that's partly why there's a cap there, and what's the incentive for people to perform to still not be overly excessively using their energy. But again, Octopus are pretty of the view that probably won't happen, but look, we're really keen to see what actually happens when people move in. The general feedback we've got from our houses is that they're in winter, they're very warm with virtually no heating on at all anyway. So we're not overly concerned around that. And that's been the case from the houses we built from day one. So that hopefully gives you a bit of feedback on what we're doing. And yeah, there's probably some more we can do on, you try to use the smart meter data and the heat pump data to get HTC automatically. And I know I've spoken to, was it Build Test around trying to do that on some of our houses.
And just a follow-up question, what about overheating concerns in the summer?
So we've done all the TM59 work around that and meet the TM59 requirements. So, but fundamentally, if we have a 40-degree summer, we're going to have warm homes again and overheating issues. So I don't think the TM59 the TM59 assessment stops really bad design.
Yeah.
And forces you to do sensible design. And I think it's a real positive step, but it doesn't stop massive overheating in homes. And the bit that we're trying to work out is effectively in the summer, we've got excess solar generation doing nothing. And actually, if you cooled a house to 27, 26 degrees, it adds next to nothing on the overall energy consumption.
Yeah.
So it's one of the things we have started to look at is active cooling something that we want to pursue at the moment? Intuitively, the answer is no, you need to design it out. But in reality, if we get some more 40-degree summers, it's going to be a customer requirement or a request, and people are going to badly retrofit it rather than design it in from the start, and they'll just buy the portable AC units, even if the house has been well designed and minimises overheating risk. So that is something which we've started to look at, because I think that is, we are going to get hotter summers, and that's something we're going to have to work out how we manage that. And we've got, on a hot sunny day, we'd have loads of spare energy coming off the solar panels that we could be driving a air-to-air heat pump to do the heating and some cooling in the summer. So that's some of the things that we're starting to look at, but we haven't made a decision on yet. But I think it's the way the market, I think, will naturally go over time. Even if you've really well designed it, you won't beat the outside temperature by much.
Yeah, thanks very much. Thank you.
Cheers, Rob. Before I sort of just bring Chris in, because it's more of a retrofit question, Ned had a follow-up question. Did you want to ask your question, Ned?
Hi there. Sure, yeah, I'm happy to ask it. The homes that you're building, obviously particularly interested in how they integrate with to being a zero build level home. Is that just compatible with air source heat pump, or do you envisage these houses that you're building being compatible with wider heat networks within an area of new houses, or say ground source networks? So
at the moment, the arrangement we've got with Octopus just covers single family homes, and the technologies we've got, which is which we use, which are air source, solar and battery. It would work with ground source if it was individual ground source. And Octopus are looking at some flats to try and see if they could do a zero builds on a block basis with sort of a solar sharing ground loop heat pump type arrangement. So I do think that is something that they're working on. So again, if you've got a site where you want to look at it, I'd say speak to Octopus and see if we can make it work. Challenge you got on blocks of flats is you haven't got much roof area per. I think when you go above probably 2 or 3 stories, you're going to struggle for the roof area to get enough PV on to generate more than the overall flats will use. So that is challenging. And I'm also wary of heat networks in lower density housing, which is the majority of housing. So in blocks of flats, absolutely makes a lot of sense. But in a low-rise housing sense, the cost of running that heat network has never made much sense. And the COP difference in performance from a good, well-installed air source on a low flow temperature heating system versus a ground source isn't that different over a year. And particularly in SAP, you end up getting a worse result out of most of the ground source heat pumps than you do an air source heat pump. But that's part of the problem with SAP. But not going to bash SAP. I think it's actually pretty good for what it does. But yeah, I agree, it does some things badly. But it does do electricity projections better than PHPP for UK housing. Would be one of the areas I think PHPP massively underestimates electricity use in UK housing. But it probably does the heating and other things better. So that.
Cool. Cheers, Ned. Yeah, I saw something yesterday that was, I think it was a Swedish heat pump manufacturer of, I don't know when it's going to come into fruition, but or production, this small, really tiny heat pumps that literally fit under a sink to work in blocks of flat with heat networks. And like you were saying earlier on, you know, by the time we get towards 2030, 2035, you're hoping that you're trying to solve the problem now with what you can work with. You know, there is going to be new innovations coming along, and obviously it's going to change once again. And these smaller heat pumps sound like they could solve a issue.
One thing on smaller heat pumps is our heat pumps aren't sized based on our heat demand. Our heat pumps are sized based on our hot water demand, and most new build housing will be sized, the heat pumps based on the hot water demand. If you've got a big bungalow with low usage, you might want to size it on fabric load.
Yeah.
But most of it now is around the reheat time on the cylinder. and that's on our, we've got I think those homes have got 3.5 kilowatt Valent heat pump in it,
Right.
but the steady state heat loss is 1.2 kilowatts, I think. So, but it's the reheat time on the hot water cylinder which drives the 3.5 kilowatt heat pump, not the fabric demand. So, you're always going to need a 3 to 4 kilowatt heat pump in a 2-bed or even a 1-bed house, I think, or flat. So,
yeah.
But the heat pumps that fit on top of the cylinders, there's some interesting stuff there. I think they make a lot of sense for flats. Yeah.
Cool. Chris, did you want to ask your question? Albeit Nigel's obviously a new home builder, but it's
yeah, sure. My concern is the existing stock. It always has been in several respects. There are several aspects to it. One is how you incentivize people who have relatively large houses with solid walls and so on, that where energy doesn't seem to be a factor in the pricing of them. The other aspect is that if you do start to influence the pricing of houses according to energy, you're going to end up with underwater houses, in the sense of how do you amortize the loss of value of highly priced assets? What impact does that have on the economy? Now, I heard, I think it was somebody from a ministry talking about involving the private sector for loans. And what occurred to me was perhaps their idea is that you get a private loan and it's a charge on the property, a bit like a mortgage. But I mean, overall, to get back to your sector, is your view that we replace the existing stock with factory produced houses like this where we can control the quality?
At the moment, my view is stock that's there we need to try and upgrade it, decarbonize it, make it affordable to heat, and keep as much of the existing stock we've got, because we need more housing, and the embodied carbon of knocking down and rebuilding isn't great. So I would advocate a retrofit first approach. I think there is some stock which, if you have effectively got to build a new house around the outside of it to retrofit it, and I've seen some of the retrofit projects that have been done through the Social Housing Decarbonisation Fund and some other things costing over £100,000 a house. There is some stock where it may make more sense to knock down and rebuild, but I think we need more houses. We need to try and keep as much as we can and build more in areas where it makes sense to do so. I was involved in trying to, when I was at Keepmoat, looking at retrofit and Green Deal, which sounds like what you're talking about in terms of a charge on the property and that sort of thing. It was politically toxic at the time, and resulted in lots of other things getting cut at the same time, like the zero carbon homes policy, because people didn't believe in customer desires for higher performing homes, and it was better to save 50 quid on the bill, was the perceptive at the time, rather than insulate homes. Hopefully, I think there is some political will to do things in different directions. Hopefully we'll see something tomorrow in this Green Day package that will cover something on housing. I don't know what. But my personal philosophy is that we'll need a change of government with a very different agenda to move this on at the level we need it to. At the moment, we haven't got that political will to do what needs to happen. But what we're trying to do with the zero bills is reset the bar and reset the aspiration. And make this the sort of the standard that people aspire towards, and the thought of having an energy bill in the house as being a 20th century concept, and a 21st century new home would have no bills, and that would hopefully set the consumer demand towards a better home.
Yeah, the market will react. I mean, yeah, it is a political hot potato, but people who live in larger period properties, they know they're spending a fortune, and just because they live in larger homes doesn't necessarily mean that they may have the wherewithal to undergo large retrofit projects, but from a finance perspective, they could raise it and as you said, charge against it.
There's a really interesting cost versus carbon point here, which on that sort of cost carbon balance, where you spend your money and what you do, because on fuel poverty, insulation and air tightness and behavior change are all the sort of things that make a lot of sense, but actually don't decarbonize the house very much if you're on gas or oil.
No.
And fitting a heat pump does the carbon box, but doesn't address the energy bits. And therefore, being able to afford to do both in the entire housing stock is really challenging. And that's one of the things that people are advocating for. Only build new build passive house, everything retrofit, NFit. We haven't got the money or the material budget from a carbon point of view, I think, to do both at that sort of level.
Yeah,
and
actually,
you've got to make some decisions. I think there's a sensible level of retrofit and decarbonisation, and a sensible level of new build fabric standard and decarbonisation.
you've just given me an idea, actually.
Which might get you there.
Yeah, just give me an idea, Nigel, actually, because if you think about it, if we moved over to factory production of new homes, we would liberate what skills there are in the construction sector for retrofit. But that again is a political hot potato amongst the house builders and so on with their current models. I think the other point you made that's excellent is how do we know we're doing this in the right place, given the changes in our economy? So, you know, there are examples of quite good quality houses in places where the economy is in a terrible state and they're being knocked down, but they're actually quite good build one way or another. So the real key is how do we know with the changes in the economy we're going to build these excellent homes in the right place?
We seem to be missing some of our passive house consultants in this week, so there's no one here to give you a bit of a bashing, Nigel, which is, you know, I suppose a bit of a shame. But yeah, well, we've hit 1 o'clock now, so yeah, very much thank you for your time. It's good to have questions from everyone else. A really interesting subject. I do think, you know, with my, you know, not to talk about me, but, you know, my interest in property going forward, you know, I live in an old property. If I'm going to be finding sites from a development perspective, I'm only interested in building out low carbon homes. I mean, the market will dictate from the more and more people were going to want to live in new homes now, and that's like going to change. You know, we're at a tipping point here. So I think what you're doing is fantastic. Yeah, thanks for taking the time to talk to us today. Thanks for everyone else. Remember, try and recommend someone to join Meshwork so we can hit our 2000th member this week. And yeah, thanks all for joining. And yeah, next week we have Mark Siddle. So he's a bit of an adversary of yours, is he, Nigel?
We've had some good debates on Twitter. I think we have a different view on some of this stuff, and
yeah,
the data I see points me in the direction that I've taken. He's obviously got different views, but look, I think we're fundamentally agreed on quality and design quality and other bits. It's how far you go on the fabric is probably the bits where we differ. But
yeah.
So I think we've got some really important topics to discuss next week, so should be good.
Thank you. Well, yeah, and very much enjoyed your session today. So yeah, thanks all. Cheers.
Bye.
Bye.